今日的世界是信息的世界，奔腾互联网已经家喻户晓。互联网的未来是怎样的呢？让我们与来自美国加州伯克利大学的埃瑞克·布鲁尔教授共同展望明日的互联网。
建构时代常识，享受智慧人生。敬请收看《百家讲坛》。
I'm also a Berkeley graduate, having done my undergrad there. That I'm going to talk about today, which is how to get to the next step of the internet. And I would say, if I had to pick one thing to accentuate from the first talk, I would say that if we do this right, it should be invisible. That the very best technology is that which you can't see. Because if you see it, then it can break. If you see it, you have to learn about it. A good example of this that hit me recently is how many devices in my house have clocks. As far as I can tell, this number is somewhere around 100. But it's so many that I simply will throw devices out rather than spend the time to reset the clock twice a year or more for daylight savings time. All right, this is an example of a bigger thing where something is not quite invisible. It's almost invisible. And that's okay if you have 2 clocks. It's not okay if you have 100 clocks. So when I say infrastructure, what I really mean is that the things that we depend on in computing and data storage should be just part of the infrastructure, much like the plumbing system. Plumbing system's a pretty darn good model. You turn the faucet and the water comes on. You turn it off, it goes off. I used to say this, by the way, about the power system, which doesn't quite meet its goals anymore, but it's the right goal, that it should be that present and that simple and that integrated into life. Now we have a long way to go to get there, but let's start about what I mean by infrastructure. One thing I mean is it's not actually the bandwidth. All of the growth that matters in the internet comes from this picture. It's the servers. Right, and it's the servers because the servers are what give you extensibility. That's also where the challenge is, because the servers are, in some sense, are fundamentally less reliable than wires. Wires aren't perfect. They're certainly more reliable than servers. So this is actually an actual cluster from one of the Inktomi sites. And the way to think about this is this cluster, which, by the way, is rarely lit. It's unusual to have the light on because there's no people in this room, and the light's only for the people. All right, so the way to think about this is a rack of machines in the middle of nowhere that answers questions for 100 million to 500 million people. And the kind of questions it's answering are typically the searches that are on the web. So Inktomi does about half of the searches on the web, and that's something like 100 million a day. So 100 million times a day, someone will submit a query to a search engine, not knowing that it goes to this cluster. But that's what happens to it. You type in your query, goes to the site you're at, say AOL or Microsoft or Daum in Korea, many others, and then it goes to this cluster to actually get the answer. So a search engine is a simple kind of infrastructure service and has lots of things to learn from. But one of the big ones is that this is what it looks like. Right? So when I talk about computers and PCs, I don't actually mean the stuff on your desk. I would like you to have less stuff on your desk. The only thing you need on your desk really is a monitor and a keyboard. And later we'll get rid of the keyboard too. right? Because it's kind of an annoying interface. But this is what we actually, I think, are working on, is how to make lots of these things that if I didn't show you the picture, you wouldn't know about them at all. They should be invisible. So some background first. Why is the internet different? If we're going to do something about this evolution of the internet, we ought to understand what it is and what it isn't. Here's 4 things that I think are pretty important. The biggest one historically is that people argue the internet is a new media. Much like TV or radio or newspaper were new media. That is a true statement, but as I'll argue, I don't think it's actually all that important. The most important one is the next one, which is that it enables services and not just content, and I'll talk about that in quite a minute. But in general, anytime you're using the internet, I would say most of your uses of the internet are actually services. And a good example of that is email. Email is actually a service. Your cell phone is a service too. So by service, I mean things that you typically have a long-term relationship with. Right? You have a long-term relationship with your cell phone provider with your email account. It is providing a service to you. And that's actually what's new about the internet, is that it's a service media and not a one-way distribution media like newspapers and television and radio. Another important property of the internet is it's the first media that's been subject to automation and to Moore's law. Right? There's not really been substantial change in technology in television or radio or newspapers. Right? Those processes, those media, are not subject to Moore's law. So no matter what the internet is today, you can be sure that it'll be different tomorrow. Right? And that's untrue for any previous media. And it's also the reason that in some sense I think it's the last media. There's no next media coming because the rate of evolution of this one is such that there will never need to be another one. Right? Interesting way to view it. And finally, it's quite global, and I think there's lots of evidence of that, including the fact that you can have internet access from your hotel room in Shanghai and read your email in a California web server. Right? That's a very simple but nice aspect. So let's kind of go through these a little bit more. Internet as new media. So I'm going to be a little bit controversial and say this is actually a farce. It's not useful to think of the internet as a media form, mostly because if you're just repackaging content, I think it's been proven that that is not a particularly useful thing to do. It was novel for a while, but that's different than useful. And there is some things we can do with content that's new, in particular personalization. And I would certainly argue that something like My Yahoo, which is the site I use, which has stocks and weather and directions, things like that, is a better version of a newspaper than the newspaper that has the same content. And the essential difference is exactly that it's more personalized to me. So that part I can believe is maybe new media. But as soon as you get into personalization, you're really talking about a service and not content. And I'll talk about that more in a second. So this notion that content is king and that the people that have content will be the people that rule the internet is strictly wrong. And in fact, there's good evidence for this in lots of simple ways. Like if you go to some of these content kings, I would think of groups like AOL or Yahoo, and you ask them, what is it that you do that keeps your users? Why do they stay with your site? And they will not say it's because of our content. They will say it's because of our email, number one, and our stock quotes, number two. Those are the two most sticky things. Sticky is the word we use. Sticky means that once you start using that feature, it's hard for you to leave and use another site. So I think you all understand that email is sticky. What that means essentially is that once you give out your email address on your business card, it is somewhat painful for you to change your email address. Right? Because now you're going to have to track down all the people you gave your cards to and update their information, which, by the way, we could automate in the future. But for now, it's a big pain that your email address is sticky because it's hard for you to change. Likewise, Yahoo told me that their stock portfolio is very sticky. Once people enter the list of stocks that they own, and they can use it to track their portfolio, that's an investment they've made in that site because they've taught it something. And when you teach a site something, you're stuck with it, right? Because if you want to move, you're going to have to teach the new site to something else. And by the way, the people who run the site that you taught are never going to hand over that information to another site so that you can switch. It's not in their economic interest. Right. So it's the services, which is where I'm going, that is what actually matters about the internet. Conveniently, the whole economy is moving to services anyway, meaning that there's a nice piece about this in the paper about China yesterday, which said that although manufacturing is going to be struggling in China over the coming year, there's a boom in the service economy that's going to make up for that. Well, that's great news. What is the service economy? It's essentially this idea that the economy is tied more to relationships and services than it is to actual output, which is the traditional metric of an economy. So this actually is a good time for the internet to enable services, because the services are essentially the fastest growing part of the economy anyway. So the right way to think about the internet is it's a platform for services. That if you are trying to have a company on the internet or a university, the thing that you need to think about is what are the services I'm providing, and by service again I mean that what's the long-term relationship I'm going to have with the person at the other end of the wire, right? And it's the relationship that's going to matter in the long term. And what's unique about the internet is exactly that it enables you to have a relationship with millions of people, and millions of people in a personalized way. There's also practical reasons why this is the right way to think about the internet, the biggest of which is services, because they're long-term relationships, can have contractual relationships, they can have subscriptions, right? They tend to have business models that make sense, right? If an internet is just a media, then its only business model is advertising, and it doesn't make sense in the long term, right? So if you view the advertising part of the internet as a fad, then the real part of the internet is still coming, which is that relationships are based on typically contractual relationships and services. And you already have many of these. You have a contractual relationship with your ISP. You probably have one with your cell phone carrier. Today those two are different. They may be the same in the future. So that's what I mean by a service and a contractual relationship. They show up on your credit card bill every month. That's probably a good definition of a service. Right. That's lots of things would like to have that business model, including, by the way, most software companies, Microsoft and Oracle, are both moving to models where they get paid per use or paid monthly for their software rather than a one-time transaction. So this is all kind of the same general direction. So I would say content is not king, services are king.
今日的世界是信息的世界，奔腾互联网已经家喻户晓。互联网的未来是怎样的呢？
The last boom in the economy was more than anything else due to the ability to search. Not only do I want this infrastructure to be global and invisible, but I want it to be I want its global nature to be part of what makes it highly reliable.
建构时代常识，享受智慧人生。敬请收看百家讲坛。
Subject to automation. Well, there's lots of uses here. I think it's not completely ridiculous to make the argument that the last boom in the economy was more than anything else due to the ability to search. Now, I'm a search bigot, so it's a highly biased statement coming from me. What I mean by that is that there was, in fact, a measurable increase in productivity, and I would argue that increase came from the ability of people to find information more quickly. That, in fact, people are more productive, and I would think this even applies to yourselves, and you can do a little test, which is, have you done a search on an internet site, or that includes, by the way, eBay and FedEx tracking and all kinds of things. Those are all searches. Have you done on a search in the last few years that you wouldn't have been able to do at all in the past? And for me, being an internet search guy, I would say that's true many, many times over. Good examples are, if I want to know some piece of information, I will go to the web and look it up. Whereas before I would have just given up as being, I'm sure that's in the library somewhere, but I can't possibly have the time to go look it up and find it. And it's not clear I would know even where to look for some pieces of information. So the ability to ask any question I want, anytime I want, has changed not only my productivity, but what I'm willing to try. It's made me more ambitious. And I think that culturally, at least in California, which it's a small subset, you can see in people that it's made them more ambitious. A good example is if you have a party, you tend not to give out driving directions. Why is that? Because you now assume that the people coming to your party can look up driving directions on the web. Right? That we expect them to have that capability that they didn't have before. Right? So that's a change in productivity that I think is very fundamental. And a more classic economic example would be eBay, where essentially there are no local auctions in California anymore. It doesn't make any sense to have a local auction where you can reach a small number of sellers if you can instead put something on eBay and reach 100 million potential sellers or potential buyers. Right? That the scale of what you can get out of infrastructure changes the economics even in the small. These are all examples of automation and reach. And finally, the other thing I think is really different about this media is how global it is. And this came to me accidentally on Ink2Me just by the fact that we ended up being on 4 continents our first year, right? So we'd have maybe 50 people, but we had customers in Japan, in Australia, in Europe, in the US. And it wasn't because we intentionally went after those markets, it's because it didn't matter where the customer was and where we were. You can't have a local market in the long term. The only way to have a local market in the long term is through regulation that bars external competition. And I'm not going to get into whether that's a good or bad thing, but it's certainly something that has to be, that's different about the internet, much more so than anything else. So this is an example of some of this. I showed you those clusters earlier that do searches for the internet. There's actually 8 of those clusters. They're in different parts of the world. The users of them are in different parts of the world. And in some sense, what's interesting about this is that from the very beginning, this is a global infrastructure. For example, one of the things that happens is to look at what would happen if we had an earthquake in California. Well, we have about 3 data centers in California. Chances are one of them might be lost completely. What would we do? Well, we might send the traffic to a different location in California. What we've actually done in testing is send traffic to London or Tokyo or all kinds of places. That this is possible now in a way that wasn't possible before. So not only do I want this infrastructure to be global and invisible, but I want it to be I want its global nature to be part of what makes it highly reliable, such that even things like terrorists or earthquakes can't actually affect the reliability of the infrastructure. That's a perfectly reasonable goal, and I think that is not a reasonable goal for any other media, including things like television that you would think of as relatively reliable. Last piece of background, there is reason to believe that not only is the internet the last media, but it's the great unifier of all media. That there's no reason to have any other media in the long term. That's a bit of a strong statement. Now that doesn't mean you wouldn't have television programs. The question is really, do you receive them on an antenna on your roof, or do you receive them over an IP-based protocol? And there's, I think, pretty good reason to believe that you'll receive them over an IP-based protocol, mostly because that protocol grows with Moore's law and antennas on your roof don't. You can say whatever you want about the advantages of the current media systems, but their rate of evolution is slow, and they will eventually be overtaken by anything that's tied to Moore's law. So you can pick your time, and we can argue about is it next year or 5 years, but it is inevitable. So here's a simple one that's interesting. The bar I care most, this is essentially home penetration. This is for US, but actually the numbers are more interesting in other countries, because other countries actually have lower presence of PCs in homes. Right, and higher presence of cellular phones. Right, so the question really is, there's no reason we can't have one infrastructure that supports all these things. Right now, these infrastructures are all separate, but there's no good reason for that, and there's lots of reasons that it doesn't make any sense. In particular, it's highly inefficient. For example, there must be 20 different ways to get data into my house right now. I don't know all of them. Some of the easy ones, of course, are TV and radio and newspaper. But then there's also probably a half a dozen cellular providers, each of whom could move data into my house, right? And they, by the way, each of them has a base station within a few miles of my house, which is highly redundant. They all have their own independent base stations. Then there's satellite. There's several satellites that have signals that reach my house. Some obvious ones are things like DirecTV and Dish Network. Those are television satellites that are intended to reach my house. Another one's GPS, which is the global positioning system. That's about 12 satellites that reach my house, maybe 5 of which might be in sight at any given time. So there's tons of infrastructure already there. It's just that it's not at all unified in any sense, right? So I'm not arguing that they're going to go away in terms of applications. I'm arguing that as infrastructures, as they evolve, they will evolve together. And I don't know what that looks like, but it's certainly important to realize that there's no reason for them to have separate infrastructure. So you'd like to have an infrastructure that supports all kinds of different devices off of the same infrastructure. And in this case, this is taken from an Inktomi slide. This is actually a very old slide for us. It's from about 1997. But could you have a device that would provide internet access to all these different kinds of devices, cell phones and PDAs and set-top boxes? And the answer is technically yes. There's no problem there. The real issue is it turns out that by itself misses the point. The point's not can you have a shared infrastructure. The point is can you make the infrastructure invisible? And then in some sense you don't care if it's efficient or not, the first order. Right? So that's, I think, in 10 years, people will look back at Berkeley and say, Berkeley was the first place that decided to work on something other than performance. And we'll see if that's true or not. But if you actually talk to the faculty at Berkeley, you'll find most of the research in computer science at Berkeley, which I think is unique at the moment, is not on performance. That's the first time that's been true basically ever, right, in any university in computer science. Right? And the reason is essentially what came up in the earlier question, is that the extra performance doesn't matter compared to the simplification of life. So this picture is wrong in the sense that it's focusing on how to make the thing more efficient rather than how to actually make things work better. So we'll come back to that later. So what do we need to do? Well, I would say this is what's next for the internet. It's first to realize what it is for, and it's a service infrastructure. And that's not actually how we've built it. We've built it to transmit packets. We've built it to move content efficiently. We've built it to do the web very efficiently. But we've not actually made it easy to create and operate services that can handle 1 billion people and be up all the time. So this is I think the actual target. We aren't that good at this yet, but the good news is this is the kind of thing Berkeley is good at. In fact, I would argue Berkeley is the very best place historically ever for the creation of infrastructure. That the databases and the operating systems have always come out of Berkeley, right? It's because in some sense that's what we like to work on, right? Is the infrastructure side of it. So what do we have to get to happen for these service requirements? Every service, I think, should be able to handle every person on the planet. That should just be its target goal. And it turns out that's not so hard. I would say 10 years ago, I would have said that was impossible. 5 years ago, I was worried about supporting 10 million people. Today, we support 100 million people every day, and it doesn't seem hard to go to 1 billion people. There's 1.1 people in the developed world, so we could certainly get all the developed world using what we have already. And I don't see any reason why we couldn't get to 10 billion people. Although then you have a different problem, which is would those 10 billion people rather have water or internet access? And that's, I think, actually, there's a good debate there, which I don't have time for, but the argument for internet access is that it increases the chance that they can get water themselves. That it changes, it's essentially a social mobility mechanism and an education mechanism that makes all the other problems easier. It's got to be up all the time. This is part of being invisible. I would like the internet to be something that you depend on in the truest sense of the word. That means it can't fail. It has to be really, really reliable. And in fact, the electrical system is not reliable enough. right? Not just in California, but overall. And in fact, many of the techniques we're going to use to make computer systems more reliable will retroactively be applied to everything else, including the electrical system. Rapid growth, modular services. I'm going to talk a lot about modular services. Also, I will postpone that, but what I really mean there is right now, when someone builds a service, they're really meaning a single service that stands by itself and supports individual web users. And that's actually not the right architecture. We really would like services to use each other and to be able to communicate between computers, not just computers to people. So I'll come back to that point in a minute. And finally, we're expecting, because of Moore's law, that we can make the cost of a service per person be vanishingly small. So people ask me, what exactly do you do when you do a search, and how much does it cost? And it's a staggering statistic, but basically what we do is search through 1 billion documents, right? And we search every single word of all of those 1 billion documents, right? Every single word of 1 billion documents. We do that search in 1/4 of a second. That's how long we have to look up the answer. And we're doing 100 million of those searches every day. So if you asked me 10 years ago, could you build a computer that would search through 1 billion documents, every word, in 1/4 second, I would have said no. And I said, well, can you do it and do it 100 million times a day? I would have said no and no and no. Right? And the short answer is, you can do this, and you can do this at an incredibly low cost, again, because we're riding the Moore's law evolution. So what is the cost for all this? It's about maybe a 20th of a cent. So for a 20th of a cent, I can search 1 billion documents once, which means there's plenty of room in there for advertising all kinds of business models that make sense. So I think we're pretty good on that cost, but people do not understand yet just how much you can do for a penny on the internet. It's really incredible. And of course, the amount of stuff you can do for a penny is also growing by Moore's law. So this is where all those faster processors matter. It's not on your desktop, it's in the infrastructure that's going to do things for 1 billion people. In fact, would make the broader claim that one of the things that has to change about the industry is that most computers and most storage projects need to be designed differently for the infrastructure than they do for the home or the PC. And that transition hasn't really happened yet. A good example is disk drives. Small disk drives are designed for laptops. They're not designed for data centers. And they should be designed differently, given that that's where all the storage is going to be in the future. Right, so there's some disconnection still. And that's the model of the future. Right? Little change on your side, lots of change in the background. So the rate of service upgrade you have is incredible. And that gives you a kind of power that you haven't had in software before.
建构时代常识，享受智慧人生。敬请收看百家讲坛。
So next thing I want to talk about is why do I believe in the infrastructure so much? Right? Clearly one reason is that that's what I'm working on and I have an obligation to love it. But there are deeper reasons, and this is the most technical part of the talk, so I hope it's not too technical, but I think I can explain to you why you want everything to be in the infrastructure. The first reason is that you want your data in the infrastructure. Right now, our data tends to be on devices that we carry, like our laptops or cell phones or PDAs. And that's a pretty bad model for lots of reasons. The biggest reason, of course, is that you can lose that device, and therefore you lose that data. So how many people have lost their PDA or lost their paper version of that, their Filofax book, that kind of thing, right? Those losses are considered incredibly painful, right? And the short answer is there's no reason to suffer that loss. If your data was in the infrastructure, then you can't lose it, right? You lose the device, that doesn't matter. The device was merely a way to access your data. It is not the data itself. So that's a very important point. You can do groupware, things like calendars. It's very hard to do schedule meetings with different people unless everybody's calendar is together. Right? The easiest way to get everyone's calendar together is put them all in the same place, and then it's easy to schedule meetings. So some calendar programs like Outlook already work this way. That's just an example of something that's in the infrastructure. Now, it also turns out that you can have faster access this way. I'm not going to talk too much about this. Let's talk about, I think, two more that are related, which is that when I think about infrastructure, I think of it as being cheaper. And this is a little bit of a hard argument for people to understand. But the way to think about it is, how many modems does AOL's user base have? Well, there's 30 million users, so they probably have about 30 million modems. How many modems does AOL have? Well, they have about, so your first guess would be 30 million, because every connection needs a modem on each end. That's not true. They have about 1 million to 2 million modems. So why can they get away with so few modems when they have 30 million users? And that is, the answer is because not all 30 million users are online at the same time. So in general, utilization for individuals is very low, like about 4% or 2%. So how often are you actually using your laptop? How often are you actually using your modem? You're actually using your cell phone? That utilization is very low. Anything you put in the infrastructure has very high utilization, because in some sense, we buy equipment as we need it. So utilization might be 60 to 80%. And if it gets higher than that, then we buy more equipment to bring it down to 60 to 80%. And if it's lower than that, we in fact sell equipment to somebody else and lower our operating costs. As it turns out, you can make things 10 to 20 times simpler, right? Because if your end device is doing less, then it will cost less, it will weigh less, it will use less power, right? So in general, we want to move as much stuff as we can to the other side of the wire, the infrastructure side, right? For lots of reasons, but one basic one is it's 20 times cheaper. That also means, by the way, that your device has a longer lifetime. So you shouldn't really care if you have the fastest laptop if all it does is access the infrastructure. What you care about is the infrastructure fast? Right. So what this tends to mean, and this is a little bit hard to quantify, is that devices you have that are tied to the infrastructure last much longer than devices you have on your desktop that you have to upgrade every 6 months or a year. Right? Because the service provider is doing the upgrading for you in some sense in the background invisibly. Your device, since it doesn't change what it does very often, doesn't need to change very often. So the hope here is that a side effect of moving things into the infrastructure is that they should become simpler and less complicated. That you shouldn't be installing software. If you're installing software, that's a misuse of the infrastructure. Right? The people that own the infrastructure should be installing software, and they should be dealing with all that headache, but you shouldn't. Right? And the first order of this is true for websites, meaning once you have your browser working, they can change that website every day, and you don't make any changes on your side. Right? That's a much simpler existence, and that's the model of the future, right? Which is little change on your side, lots of change in the background. And it's up to them to make sure those changes are safe and preserve your data and all that stuff. And that's essentially exactly how it's going. So one more pair that is related to this. And I already talked that there's some evidence that we should have one infrastructure. I call this superconvergence. But there's already things I would like to see that are easy to see in this model. So one of them is that there's no reason you shouldn't be able to have everyone on a teleconference looking at the same PowerPoint slides. Right? We do this today using the following low-tech solution, which is we have a telephone conference, and one of the people says which number slide to look at. Right? Or they say, next slide. And that is the cue to all the people in other conference rooms to advance the slide. And of course, people get off sync and say, what slide are you on? I'm lost. Right? So there's a very simple one where if you had one infrastructure, it would be very easy to cause, when I advance my slide, your slide advances too. Right? This is not rocket science. Right? This is very simple stuff. Another easy one is I would like to be able to have my addresses on my PC and on my website, but not have to enter them on my cell phone. So how many numbers have you entered on your cell phone? And how many addresses have you entered on your PDA? Right? There's no reason for that. You should enter them on your PC where you have a nice big keyboard and it's easy and you can edit and you can move the mouse. Right? It should be the infrastructure's job to get those address and phone numbers from your PC into the infrastructure and then into your cell phone, into your PDA. Those should all be interchangeable things. They shouldn't have, in fact, another way to think about this is how many places do you have a given phone number written down? Right? It should be one. Right? And really, I mean one in the infrastructure. And of course, it's up to the infrastructure provider to do replication of that for security and availability. But the bottom line is, you should have one copy of everything that you care about, and then the only question is, how do you access it? Right? That's a solvable infrastructure problem. Different model. This last one, I think, is the most important and most interesting aspect of all of why things should be in the infrastructure, which is the rate of evolution and the rate of innovation is much higher for services than it is for products. So if I have a product like Microsoft Office, doesn't matter what it is, that product gets updated relatively infrequently. Say you had Microsoft Office 98 and then you had Microsoft Office 2000. I would say it's 2 years roughly between upgrades, right? And you had Office 97 to 98, maybe that's a year, doesn't much matter. Right? Long time. Why is that? Two big reasons. One reason is you have to physically distribute the new version to all the people that use it. That's a hard problem. The most common way it's done, by the way, is you buy a new PC and it comes with new software. Right? That's an awkward way to distribute software, but it's the most common one we use. The other reason that products have this long upgrade cycle is that they have to be tested in many, many different configurations. So I would say Microsoft would argue that their biggest challenge is to make sure that a new OS works with all the existing applications that they didn't write. Right? And somehow they're responsible to make sure that they work, which is in some sense unfair to them, but nonetheless that's the expectation. In the services model, there is one copy of the software that runs in the infrastructure. And the people that write the software can be the same people that operate it. And the big advantage of that is that they can then upgrade it as much as they want, and they can test it as much as they want, and they can upgrade it every day if they want to. So in fact, this is exactly what happens with sites like search engines, where we typically will make a change about twice a week. Right? You couldn't imagine changing Microsoft Office twice a week. It's not physically possible. But on an infrastructure service, because it's such a controlled environment, you can in fact change it every day if you want to. And sites like CNN change it every 15 minutes. They change content. Right? So the rate of service upgrade that you can have is incredible, and that gives you a kind of power that we haven't had in software before. So I would also argue that this is the direction that all product companies will go. Let me check my time. Almost out of time. So what else do we have to do? Well, it turns out that it's easy to do services for humans and very hard to do services that are for other computers. And this is one of the things that XML is supposed to fix. But let me just be clear what I mean. Human-human service would be email or chat, where the computer is a mediator, but it's not an endpoint in either sense. That you're talking to a particular human. You may not know who it is in chat, but you know there's another human on the other side. And then there's human-computer interactions, which is typically the web, where you are interacting with a server and it gives you some answer. And what most people don't understand is that that only works because a human is there to interpret the answer. HTML and web services tend to be very, very sloppy. And it turns out that doesn't matter to a human because we can look at it and say, oh, that's an ad, we'll ignore the ad, although it's occasionally hard to tell, right? And we can say, oh, this is badly formatted, but I can still figure out what it's supposed to be. Or this got stuck, and I know if I hit the reload button that it'll work if I try it again. Although that's not, by the way, always true. So the web depends on your being able to interpret stuff that's bad, being able to hit reload because the system didn't work quite correctly. And when we do computer-computer interactions, we can't have a human be in the loop. And it turns out that makes the problem incredibly harder. In fact, there's a basic question, which is, why was it that computer scientists didn't invent the web? Right? People may not realize this, but the web was invented by physicists, not by computer scientists. And the answer is computer scientists weren't willing to build something that didn't work. Right? That's not in the model of a computer scientist's head. All right? We looked right to the third problem, computer, and said, we don't know how to do that, therefore we won't do the first two, right? Which is, in retrospect, stupid, right? Because clearly the first two are quite valuable by themselves. But the future of the internet depends on the third one, and that's actually good for computer scientists because now finally we get to have a role in the creation of the future web. Now, XML is supposed to fix this. I'll it turns out this is not easy. XML is a language that's supposed to describe data. It turns out it's kind of like agreeing on the alphabet that you're going to use to communicate. It's an important step, but doesn't help you communicate by itself. So, in particular, we're not good at saying what things mean. Right? So when you have two computers talking, they have to be very precise. They have to agree on the meaning of every term. Right? When you see something like price on a web, you're able to interpret what that means. And maybe you can guess the dollar sign, and it's a U.S. site, it's probably U.S. dollars, and not Canadian dollars or Hong Kong dollars. Right? Computer has to be told all that stuff explicitly. And turns out, not very good at that and not ready for that. So this is going to be the hard part, that we can get the computers to talk, we can't get them to understand each other. All right, so XML is in some sense avoiding the hard part of the problem, which is, do we understand what things mean? All right, and for a human, it's easy to get what they mean, because humans interpret English, which is by definition a very ambiguous language, as is Chinese or any other language. Right? Computer languages can't be that ambiguous. So where are we going? Well, we've had the internet as the new media phase. That was essentially about HTML and search. We've had a bunch of consumer services, which is where I think we are today. These are human computer services, and there's lots of good examples, but shopping and eBay and travel are the kinds of things I have in mind. The hard part is the industrial, what I call nested services. And I think this is really where most of the battle is going to be for the next internet. And in some sense, if you look at something like Windows XP, it's trying to be the base for this industrial nested services, that it's going to use XML and SOAP, which is its protocol, to allow other computers to access services and allow you to build a big service using lots of little services. That's the right vision. In fact, I worked on that at Berkeley for a Ninja project, but it's much harder to do, and frankly, I didn't make much progress on it. Right? But that's okay, we made some progress, and I think it's still the right direction. And finally, once we get to the ability to have computers and computers interact on the internet, then we can really get to the real goal, which is having everything in the infrastructure to the point where you don't really worry much about what's on your desktop. It just shouldn't be that important. Right? And it shouldn't matter to you if you have the latest processor. What should matter to you is, does your infrastructure provider have the latest processor? And in fact, later you won't even care about that. You only care about, do they do what they say they're going to do? Right? And at that point, the infrastructure is invisible. That's the goal. So let me stop here. So, thank you.
建构时代常识，享受智慧人生。敬请收看《百家讲坛》。